Hello, Sir Jarby. We've come to report on the priority scheduling. We hope you enjoyed our presentation. Thank you very much. What exactly is CPU scheduling? CPU scheduling is a process that allows one process to use the CPU while another process execution is on hold due to the unavailability of any resource for allowing the CPU to fully utilize. The goal of CPU scheduling is to make the system as efficient, fast, and fair as possible.
Types of CPU scheduling. Non-preemptive scheduling. In non-preemptive scheduling, once the CPU has been allocated to a process, the process keeps the CPU until it releases the CPU, either by terminating or by switching to the waiting state. Preemptive scheduling. In preemptive scheduling, if a new process arrives with a higher priority than current executing process, then it will preempt or interrupt current executing process and start its execution on CPU. The major advantage of preemptive scheduling is that high priority processes will not have to wait for long periods behind lower priority processes. When scheduling is preemptive or non-preemptive. To determine if scheduling is preemptive or non-preemptive, consider these four parameters. Number 1. If the number of process is 1, there is no context switching and hence no preemption. So the scheduling is non-preemptive in nature. Number 2. If all the processes are arriving at time 0 and there is only one CPU, then the process that comes first will be executed first without any preemption. So the scheduling is non-preemptive in nature. Number 3. If all the processes have the same CPU burst time, then again there is no question of preemption, hence it will be non-preemptive in nature.
Example types of CPU scheduling algorithm. CPU bounce job can be scheduling in one queue and all. I/O bound jobs in another queue. Example first come first serve. First come first serve FCFS. A scheduling algorithm simply schedules the jobs according to their arrive time. Example of shorting remaining time (SRT) is preemptive scheduling.
Important CPU scheduling terminologies. Burst time or execution time. Burst time refers to the time required in milliseconds by a process for its execution. Burst time takes into consideration the CPU time of a process. Arrival time. Arrival time is the point of time in milliseconds at which a process arrives at the ready queue to begin the execution. Finish time. Time at which process completes its execution. Multiprogramming. The objective of multiprogramming is to have some process running at all times to maximize CPU utilization. Jobs. Job scheduling is the process where different tasks get executed at predetermined time or when the right event happens. User. It is kind of program having user interaction. Process. It is the reference that is used for both job and user. CPU I/O burst cycle. Process execution consists of a cycle of CPU execution and I/O wait. Processes alternate between these two states. CPU scheduling criteria. Maximize CPU utilization. The main objective of any CPU scheduling algorithm is to keep the CPU as busy as possible. Theoretically, CPU utilization can range from 0 to 100, but in a real-time system, it varies from 40 to 90% depending on the load upon the system. Throughput. Throughput is the amount of work completed in a unit of time. In other words, throughput is the processes executed to number of jobs completed in a unit of time. The scheduling algorithm must look to maximize the number of jobs processed per time unit. Minimize waiting time. Waiting time is the total time spent by the process in the ready state waiting for CPU. For example, consider the arrival time of all below 3 process to be 0 ms, 0 ms, and 2 ms, and we are using the first come first serve scheduling algorithm. Then the waiting time for all the 3 processes will be P1 0 ms.
Response time. Response time is the time spent between the ready state and getting the CPU for the first time. But the waiting time is the total time taken with the process in the ready state. Let's take an example of a round-robin scheduling algorithm. Turnaround time. Turnaround time is the total amount of time spent by the process from coming in the ready state for the first time to its completion. Interval timer. Timer interruption is a method that is closely related to preemption. When a certain process gets the CPU allocation, a timer may be set to a specified interval. Both timer interruption and preemption force the process to return the CPU before its CPU burst is complete. What is a dispatcher? A dispatcher is another component that is involved in the CPU scheduling function, which is the module that gives control of the CPU to the process selected by the short-term scheduler. It receives control in kernel mode as the result of an interrupt or system call. Functions performed by dispatcher. Content switching, switching to user mode, moving to the correct location in the newly loaded program.
Types of CPU scheduling algorithm. Number 1, first come first serve or FCFS. Number 2, shortest job first or SJF scheduling. Number 3, shortest remaining time. Number 4, priority scheduling. Number 5, round robin scheduling. Number 6, multi-level queue scheduling. First come first serve or FCFS is an operating system scheduling algorithm that automatically executes queued requests and processes in order of their arrival. It is the easiest and simplest CPU scheduling algorithm. In this type of algorithm, processes which requests the CPU first get the CPU allocation first. Characteristics of FCFS method. It offers non-preemptive or preemptive scheduling algorithm. Jobs are always executed on a first come first serve basis. It is easy to implement and use. However, this method is poor in performance and the general wait time is quite high. Shortest remaining time, also known as shortest remaining time first or SRTF, is a scheduling method that is preemptive version of shortest job next scheduling. In this scheduling algorithm, the process with the smallest amount of time remaining until completion is selected to execute. Characteristics of SRT scheduling method. This method is mostly applied in a batch environments where short jobs are required to be given preference. This is not an ideal method to implement it in a shared system where the required CPU time is unknown. Associate with each process as the length of its next CPU burst so that operating system uses these lengths, which helps to schedule the process with the shortest possible time. Priority-based scheduling. Priority scheduling is a method of scheduling processes based on priority. In this method, the scheduler chooses the tasks to work as per the priority. which is different from other types of scheduling.
Round-robin scheduling. Round-robin is a CPU scheduling algorithm where each process is assigned a fixed time slot in a cycle way. It is simple, easy to implement, and starvation-free as all processes get fair share of CPU. One of the most commonly used technique in CPU scheduling is a core. Characteristics of round-robin scheduling. Round-robin is a hybrid model which is round-driven. Time slice should be known, which is assigned for a specific task to be processed. However, it may vary for different processes. It is a real-time system which responds to the event within a specific time limit. Shortest job first. Shortest job first is an algorithm with which the process having the smallest execution time is chosen for the next execution. This scheduling method can be preemptive or non-preemptive. It significantly reduces the average waiting time for other processes awaiting execution. Characteristics of SJF scheduling or short job or shortest job first. It is associated with each job as a unit of time to complete. In this method, when the CPU is available, the next process or job with the shortest completion time will be executed first. It is implemented with non-preemptive policy. The algorithm method is useful for batch type processing, where waiting for jobs to complete is not critical. It improves job output by offering shorter jobs, which should be executed first, which mostly have a shorter turnaround time. Multiple level queues scheduling. Multiple queue scheduling is queues when processes in the ready queue can be divided into different classes. Each class has its own scheduling needs. For instance, foreground or interactive processes and background or batch processes are commonly divided. Characteristic of multiple level queue scheduling. Multiple queues should be maintained for processes with some characteristics. Every queue may have its separate scheduling algorithms. Priorities are given for each queue. The purpose of a scheduling algorithm. Here are the reasons for using a scheduling algorithm. The CPU uses scheduling to improve its efficiency. It helps you to allocate resources among computing processes. Maximum utilization of CPU can be obtained with multi-programming. The processes which are to be executed are in ready queue. The main purpose of scheduling algorithms are to minimize resource starvation and to ensure fairness among the parties utilizing the resources. Scheduling deals with the problem of deciding which of the outstanding requests is to be allocated resources.
This is the output of our program. The number of process is 1, burst time is 2, waiting time is 0, and turnaround time is 2. So the average wait time and average turnaround time is 0.2.
Is the computer language that we use in this program, and the class name was Group 4. PP for means priority, BT for burst time, P for process, W for wait time, T for turnaround time, AWT for average time, and ATAT for average turnaround. Our resolution was already on the program to compute this thing. Thank you.